Hello everyone, welcome back. This is part 2 of section 6.2. In this video, I'll be demonstrating a couple of problems. Find the volume of the solid obtained by rotating the region bounded by the given curves about the specified line. Sketch the region, the solid, and a typical disk or washer. So the curve given is y equal to x cube and y equal to x. There are two curves, and x is more than or equal to 0, positive or 0, and it is rotated about the x-axis. So I have drawn here in green y equal to x, which is a straight line passing through the origin. Then the cubic curve y equal to x cube. It's given that yx is more than or equal to 0, so we don't consider the part below the x-axis. So x is more than or equal to 0. So we consider only right side part of the graph. And they both, we have to see where the two graphs meet, even though we know where it exactly meets, but we will prove it analytically where the two graphs meet. Then when it is rotated about the x-axis, what you see is this graph, the second graph. So when it is rotated about the x-axis, because it's made up of two curves, y equal to x and y equal to, this is y equal to x graph, and the below you see that y equal to x cube graph. It's rotated about the x-axis, so when it rotates, you see a gap between the region and the axis of rotation. The axis of rotation is the x-axis. So there is a space between the region, this region, and the axis of rotation. So you're definitely going to have a washer. Washer will have an outer radius and an inner radius. Outer radius comes by the outer curve, which is y equal to x in this case, which is a straight line. And the inner radius comes out of the inner curve, which is a cubic graph here. So in step 1, we will first state that find out the point of intersection. We will find out the points of intersection of the two curves. Why do we need this? We need the lower limit and the upper limit. So points of intersection of the two curves. You have to set the two y's to be equal. So x becomes equal to x cube. So which means x minus x cube equal to 0, or x times 1 minus x square equal to 0. Either x equal to 0 or x equal to plus or minus 1. So 0, 0 is 1 point. We can ignore the one with the negative 1. So we consider only the all x above, all x more than or equal to 0. So this point is 1. If y coordinate, x coordinate is 1, then the y coordinate is obtained by plugging into the line y equal to x or y equal to x cube, the cube 1. So when you plug in x equal to 0, y equal to 0. When you plug in x equal to 1, y equal to 1. So the points of intersection are zero, 0, and 1, 1. So now that determines up to what value we need to get the integral. Then the second step is to make a washer. So consider a cross section which is a washer here at a distance x from the origin. So we will call A of x to be the area of the washer. So as I said, whenever the solid is rotated about the x-axis, you will get a function of x. Whenever it is rotated about the y-axis, you will get a function of y. So area of the washer, which is pi outer radius square minus pi inner radius square. So pi R2 square minus pi R1 square. So R2 is the outer radius, which is the distance from here to this one. That will be y equal to x. Y outer minus pi y inner square. So outer is the x, so y equal to x. Inner is y equal to x cube and its square. So it will be pi times x square minus pi times x to the 6. So what is the thickness of this washer? Thickness is delta x, because we're making a slice perpendicular to the x-axis, so the thickness will occur along the x direction, which is delta x. Now the volume of this disk of the washer, A of x delta x, so which will be pi x square minus x to the 6 times delta x. So we got a typical washer volume, and we have to do this for all the washers running from 0 through 1. So that's where the point of intersection of the curves are. So we will evaluate the integral. To find the volume. Required volume. So V for volume equal to integral 0 to 1 A of x dx. Delta x turns out to be dx in the integral. Integral 0 to 1. So how do you know what the bounds are? The bounds are from x equal to 0 to x equal to 1. So x coordinates of the point of intersection. So A of x is pi x square minus x to the 6 dx. That is pi x cube over 3 minus x to the 7 over 7 between 0 and 1. So volume is pi 1/3 minus 1 over 7. The lower limit is all 0. That is pi 4 over 21. So it is 4 pi over 21 cubic units. Okay. So first figure is important. Then you have to say it is rotated about the x-axis or y-axis. In this case, it's rotated about the x-axis. You need to find the bounds. So which means you have to get the point of intersection. You have to decide whether it is a disk method or a washer method. Normally, whenever you have a gap between the region and the axis of rotation, it will be definitely a washer. If there is no gap between the axis of rotation and the region, it will be a disk method. Okay. So that finishes this problem. We'll try another one. Watch my next video for one more problem of this same section.